Hello, greetings to everybody. Welcome to my video tutorial. In this video tutorial, you'll learn how to simplify sets. That is simplification of sets. Now, before we learn how to simplify sets, there is the need for us to understand what we refer to as perfect square numbers. Perfect square numbers. Now, what is a perfect square number? A perfect square number is simply any number that we can simplify its root in order to get a positive integer. A perfect square number is any number that you can simplify its roots in order to get a positive integer. Example of a perfect square numbers are 1, 4, 9, 16, 25, 36, 49, etc. And we take note that root of 1 is 1, root of 4 is 2, root of 9 is 3, root of 16 is 4, etc. Okay, so for all of these numbers here, the 1, 4, 9, 16, 25, 36, 49 are perfect square numbers because you can simplify the roots to get a positive integer. Now let's also discuss the product rule for sets. Product rule for sets. The product rule for sets states that if root of A and root of B are real numbers, then root of A times root of B is equal to root of AB. Example, root of 4 times root of 9 will give us root of, that's 4 times 9. 4 times 9, which gives us root of 36. Also, let's look at the quotient rule for sets. Quotient rule for sets. The quotient rule for sets states that if root of A and root of B are real numbers, then we can say that root of A over root of B is equal to root of A over B. So example, root of 4 over root of 9 is equal to root of 4 over 9. Simplifying this gives us 2 over 3. So now we make use of these basic concepts, that's perfect square numbers, the product rule for sets, and the quotient rule for sets to simplify sets. Now let's look at examples. Simplify the following sets. So our first example is root of 8. How do we simplify root of 8? Solution: A, root of 8. So to simplify the set root of 8, you write the factors of 8 You see, the factors of 8 are 1, 2, 4, and 8 itself. So out of these factors, you pick two numbers that when you multiply, you get 8. But the two numbers, one must be a perfect square number. In this case, if you look through this one, you see that 4 is the perfect square number. So you choose 4. Then you also choose another number. Then you multiply by 4, you get 8. That is 2. That's 4 times 2 is 8. Hence, you rewrite the root of 8 as root of 4 times 2. Then we make use of the product rule for surds. Don't forget that the product rule for surds says that root of AB is the same as root of A times root of B. So we can write root of 4 times 2 as root of 4 times root of 2. And we all know that root of 4 is the same as 2. So root of 4 is 2 times root of 2. Then we have 2 times root of 2, which gives us 2 root 2. Now B, root of 27. Again, to simplify root of 27, you find two factors of 27, but one of the factors must be a perfect square number and the other must not be a perfect square number. So we pick 3 and 9. You know that 27 is same as 9 times 3 or 3 times 9. In this case, the 9 is the perfect square number and the 3 is not a perfect square number. We continue to rewrite this one as root of 9 times root of 3. The root of 9 is 3. So we have 3 times root of 3, which gives us 3 root 3. So root of 27 the same as 3 root 3. Now C, we have to simplify root of 25 s squared. So this example has a variable in here. The variable is s squared. By the same way, you can use the product rule for surds to simplify. What we do is that we rewrite the root of 25 s squared as root of, this is same as root of 25, let me separate it, times s squared times s squared. And by the product rule for surds, this is same as root of 25 times root of s squared. And we all know that root of 25 is 5. So we have 5 times root of s squared gives us s. This gives us 5 times s, which is 5s. So root of 25s squared is the same as 5s. Now D, we simplify root of 20 over root of 4. So to simplify this, you make use of the product rule and the quotient rule for surds. You know that root of 20 can be written as root of 4 times 5. In this case, the 4 is our perfect square number and the 5 is not a perfect square number. We have root of 4 times 5 all over 4. Sorry, all over root of 4. This is same as root of 4 times root of 5 all over root of 4. Here you can choose to cancel the root of 4 and the root of 4 here. You can rewrite this one as that's 2 times root of 5 all over 2. So these two cancel these two. Hence, our answer is root of 5. Now E, we have to simplify root of 50s over 2 root 2. Again, you make use of all the concepts that you've learned so far in solving this problem. First of all, we write the numerator as root of 50 times root of s all over 2 root 2. Now, this root of 50 here can be written as root of 25 times 2. That is, the 25 and the 2 are factors of 50. In this case, the 25 is the perfect square number. So you have 25 times 2, root of 25 times 2, all times root of s all over 2 root 2. So you see, the numerator here can be written as root of 25 times root of 2 times root of s all over 2 root 2. The 25 is the same as 5. Sorry, the root of 25 is the same as 5. So we have 5 times root of 2 times root of s all over 2 root 2. We can simplify this by cancelling the root of 2 here and the root of 2 there. So this gives us 5 times root of s over 2, which is the same as 5 root s all over 2. Hence, root of 50s over 2s is the same as 5 root s over 2. Thank you for watching this video tutorial. In our next lesson, we will look at how to perform operations on surds, as addition and subtraction. Thank you. Bye-bye.